Okay, welcome to the lecture on forces and motion. This is just an introduction here. First thing we're going to look at today is who is Sir Isaac Newton? In your notes, if you've downloaded those, you have this in your notes as well. Isaac Newton was the greatest English mathematician of his generation. His work on optics and gravitation make him one of the greatest scientists the world has known. According to the well-known story, it was on seeing an apple fall in his orchard at some time during 1665 or 1666 that Newton conceived that the same force governed the motion of the moon and the apple. He calculated the force needed to hold the moon in his orbit, as compared with the force pulling an object to the ground. He also calculated the centripetal force needed to hold a stone in a sling, and the relation between the length of a pendulum and the time of its swing. These early explorations were not soon exploited by Newton, though he studied astronomy and the problems of planetary motion. So when we take a look at forces in motion, we've got to ask ourselves, what is a force? Now when we take a look at this, we know that Newton mentioned that forces pull. Well, what is a force? Force is a push or a pull. Every time you push or pull something, you are applying force. Now in class we thought of some examples: pushing a desk, pushing your chair in, pulling your chair out. All these are push and pull examples. Forces acting upon us. Now the three main forces we're going to talk about today are in the screen that we see here in the roller coaster. Notice the roller coaster on the loop-de-loop. We have three forces. The blue force is gravity, weight, and that is a downward motion. The red is the apparent weight, and the apparent weight is the apparent weight of the people in the cart involved. Then we have acceleration and force, or the acceleration force. This acceleration force is the speed at which it's accelerating. We take a look at a couple items here. We notice that the amount of force you use to move an object depends on the mass. The more mass something has, the more force you have to use to make it move. When we take a look at the car, a car takes more force to move because it has a larger mass. And then the bike does not take as much force as the car to move because it has a smaller mass. As we pull this down, again getting back to what a force is. A force is a push or a pull, and this is where it gets a little more complicated. Upon an object resulting from the object's interaction with another object. Now what is that actually saying? It's saying that there are two objects. If we take a look over here, we look at that right there. Two objects. There is a force upon each of the object. When the interaction ceases, the two objects no longer experience the force. Forces only exist as a result of an interaction. So this here is on your notes as well in italics, and it's very, very important to remember that. Forces only exist as a result of an interaction. What can a force do? We have a force that has the ability to push, as the arrow is showing the jar, pushing the can across. We also have a force that can move an object by pulling, as the arrow is showing in this direction. Not only can force, push, and pull move an object. It can also stop an object, as in this example, the force is moving in this direction. We can stop it by pushing against it. And as the arrow is pointing, moving in this direction of the can, we can stop it by pulling it. What is motion? Motion is a change in position. And just as birds fly in the sky, we see their position change. We see them move. And as they move through the sky, we know that there is motion. Just like a Ferris wheel has a motor that makes it go in a circle, or the leaves blow in the wind. Again, getting back to Isaac Newton, he observed the effects of two forces. He described them as laws of motion. The two most important forces in everyday life are gravity and friction. An example, if you have a cart, gravity gives weight to the cart, makes it roll downhill. Friction is produced when two surfaces that are in contact and rub against each other. This action is what eventually slows down and stops the cart. In this slide, we will pull these items out of the box and show what is in motion and what is not in motion. So obviously, the statue would be not in motion. Skateboard, in motion. Playing pieces, not in motion. Biker, in motion. Chair, not in motion. Chair and table, not in motion. Car, in motion. Now most people would think that this is pretty basic, and it is. But the thing we need to take from this is that not all things are in motion. However, all things could be put into motion. The last thing we're going to talk about today is speed. All objects with motion have a speed. Speed is the measure of how fast something moves over a certain distance. A jumbo jet moves at about 1,000 kilometers per hour, or 621 miles per hour. Glaciers also move very slowly, less than 30 centimeters a day. That's about a foot. So as we look at the car, we know that it's going a certain distance. So as it moves, we can check its speed over that distance. Now, from what you've learned so far, go ahead and go on to Skyward if you have not done so, and take the quiz. The quiz has these questions. Weight is a force. In which direction does the force act? To stop an object in motion, a blank must act upon it. What is a force? In which direction does the weight force act? The engine in a car provides a force that drives the car forwards. In which direction does this force